Hello, good day. Once again, you are welcome back. In this virtual class, uh, I will take us through our trigonometric identity using the Pythagoras theorem. That is, from our right angle triangle, the sum of the square of the two adjacent sides is equal to the square of the hypotenuse. Okay, so or we simply put that the square of the hypotenuse is equal to the sum of the square of the two adjacent sides. Now, this theorem provides some useful and fundamental relationship between trigonometric ratios. Now, before we proceed, let's take a look at these uh, identities and see what they represent. So, like sec, for instance, sec theta is 1 over cos theta. We can easily do that by looking at the third letter from the left hand side, which is C, inverse of cos. Now cosec is 1 over sine theta, which is the inverse of sine, while cot is the inverse of tan. Okay, but tan theta is also sine over cos. This is the ratio. Now let's look at this diagram here. We have an ABC, triangle ABC, and this is angle 90 here. The side facing the angle 90 here usually is referred to as the hypotenuse, okay, which is arrow represented by arrow here, where AC is represented by Y and BC is represented by X. Okay, this is Y axis, this is X axis. Okay, now let's establish the Pythagoras theorem here. We specify that if this length is known, so the square of this length AB is equal to the sum of the square of AC plus BC. Okay, R square is equal to S square plus Y square. Now let's divide equation start through by R square. This become S square over R square plus Y square over R square is equal to 1. Now we can also factor equation 1 as this Y over R all square plus S over R all square equals 1. Now from the triangle ABC, we are going to look at the ratio of sine, cosine, and uh, tangent. Okay, so here we use the term here SOHCAHTOA. Okay, so the x here means sine, and the O is opposite, H is hypotenuse, and A is adjacent. That's all it is. Okay, now we're going to look at case 1. If the angle is theta, from our diagram here, if we're looking at theta alone, we see that the opposite of theta is y, which is the line AC, while the adjacent of theta, of the angle theta here, is the line BC, which is x. Okay, where the line AB is the hypotenuse. Okay, now we will use that one to establish our relationship here. Okay, now let's look at the ratio of sine here. We say SOHCAHTOA, sine is opposite over hypotenuse. And the opposite of this angle theta here is AC, which is y, and the adjacent is x, while the hypotenuse is r, which is AB. So the ratio of sine here is opposite over hypotenuse, which is y over r. Okay, you can see it here. Opposite is y, and the hypotenuse is r, which is y over r. Okay, that is established. For cosine, which is cos theta, using the angle theta here, is adjacent over hypotenuse. Look at the adjacent of this triangle is BC, which is x over AB. So here the adjacent is, that is cos theta, is x over r. Now the TOA, which is tan theta, which is the tangent, is opposite over adjacent. The opposite of angle theta here is x, and the adjacent is x, which is y over x. Now let's now show that tan theta is sine theta over cos theta. We recall that the ratio of sine is y over r, and that of cos is x over r. so that y over arrow divide x over arrow is the same thing as y over arrow. If you change the division sign here to multiplications, so that x over arrow will now be inverted, and this become y over arrow times arrow over s, which is y over x. So that is why tan is the same thing as the ratio of sine to that of cos. Okay, so now for cosec and sec, for sec we said is 1 over cos, and what is cos theta we say is x over arrow, so we invert it, it becomes arrow over x. Cosec is the inverse of sine, and sine is y over arrow, so the inverse of it becomes arrow over y. Now we have established a fact that from Pythagoras that we can also say that y over arrow square plus x over arrow square is equals to 1. If we know that y over arrow is equals to sine theta, okay, y over arrow is sine theta, so we replace it from equation 1. In place of y over arrow, we put sine theta there, so this becomes sine square theta plus cos square theta is equals to 1. So this is a very fundamental aspect of trigonometry identity. Okay. Now similarly, if we divide this equation through by cos square theta, so we're going to have sin square theta divide cos square theta plus cos square theta divide cos square theta is equals to 1 over cos square theta. So here we recall that our sine over cos is tan, isn't it? Yeah. Then 1 over cos is sec. So this becomes tan square theta plus cos square theta is equal to sine square theta. So this is a fact. Now let's also divide equation 1. Let's divide equation 1 also through. Okay, let's divide equation 2 also through by sine square theta. So sine square theta divides sine square theta plus cos square theta divides sine square theta is equal to 1 over sine square theta. Now here, sine square theta divides sine square theta is equal to 1. Then cos square theta over sine square theta, that gives cos. Cos over sine is cos. So this becomes cos square theta. And 1 over sine is cosec. And this becomes cosec square theta. So 1 plus cos square theta is equal to cosec square theta. Now in case 2, when the angle is now beta, we see that the opposite of the angle beta is x, which is base. Now let's take a look at it. This is the angle beta here. The opposite of it is x, and the adjacent to it is y. So you see that once the angle changes like that, the ratio will tend to change. But though the hypotenuse also remain the same. So here we can easily, as in case 2, we can easily see that the ratio sine beta is equal to s over r, and cos beta is equal to y over arrow, and tan beta is equal to x over y. Okay, we can easily see that here. So similarly, we can also establish that sine square beta plus cos square beta is equal to 1. Okay, so the other thing also follows. Now let's take a look at this example. Now use this diagram to answer the questions. We have a right angle triangle x, y, z. We have here xy, which is the hypotenuse as 10 centimeter, and xz, the the xz here is the opposite of the angle beta and adjacent to the angle alpha. Okay, so here we're asked to find the following: sine beta minus sine alpha, sine square alpha plus cos square beta, sine square beta minus cos square alpha, divide tan square beta, and also to show that sine square theta plus cos square alpha, sine square alpha plus cos square alpha is equal to sine square beta plus cos square beta. Now, if you look at this from here, the line yz is not known, so we can quickly use Pythagoras to establish that. For us to obtain yz, we apply Pythagoras theorem here, and this become the square root of 10 square minus a square, which is equals to 100 minus 64, which is square root of 36, which is 6. So here sine beta minus sine alpha. Let's look at sine beta from the diagram, which is xz over yz. Now sine beta here, look at beta here. Sine is opposite over hypotenuse. The opposite of this angle beta is xz, which is 8 centimeter, and the hypotenuse is x. So you can see that the ratio of sine beta is this. Now let's look at sine alpha. Sine here is different from this angle, is different from this angle. Our sine alpha here will become the opposite of, that is the opposite of this angle alpha is yz, and the hypotenuse is also yx. So this becomes 6 over 10, which is yz over xy, which is 10. So let's do the subtraction here. Sine beta minus sine alpha is 8 over 10 minus 6 over 10, and that gives 2 over 5. Now let's look at the case of sine square alpha plus cos square beta. Now this can also be expressed as sine open bracket sine square alpha plus cos square beta, so that cos square beta is yz over xy, which is 6 over 10. So if you go back here, you will see that cos beta here, which is car, which is the adjacent, which is yz, which is 6 over 10. Okay, we can see that there. Okay, then we have already know the value of sine alpha. Okay, if we substitute here, sine alpha is 6 over 10 plus the cos beta is 6 over 10. That means 6 over 10 all square plus 6 over 10 all square. That gives us 36 plus 36 divided by 100. Because since the numerator, the denominator are the same, you just add the numerator as a rule of fraction. So this eventually becomes 18 over 25. Now let's look at sine square beta minus cos square alpha divided tan square beta. So cos square alpha is xz divided yz, and xz is 8 over 10. Now similarly, sine beta is xz divided yz, which is 8 over 10. Let's go back. Cos alpha, let's look at it. Cos alpha here is is what? Is the adjacent. Okay, adjacent, this is 8 over what? Hypotenuse, 8 over 10. So that is what we obtain here. Okay, you can see it clearly here, which is 8 over 10. Similarly, we've already know the value of, look at cos alpha here, 8 over 10. Then sine beta here is the same thing as 8 over 10. Let's look at sine beta. Sine beta here is opposite, which is 8 over 10. Okay, here we can see clearly that the expression here become sine square. If you square the value of this gives us 64 over 100 minus 64 over 100 divide tan square beta, and tan square beta is 8 over 6. So since the numerator is 0, divide by this, the final answer is 0. Now I say we should show that sine square alpha plus cos square alpha is equal to sine square beta plus cos square beta. Okay, now we already established that before, but let us show it. Sine square alpha is 6 over 10, and if we square it, it becomes 36 over 100 plus cos square alpha is 6 square. Yes, cos square alpha is 8 over 10, and if we square it, that gives 64 over 100. So 36 plus 64 is 100 divided by 100 is 1. So similarly, sine squared beta plus cos squared beta, cos sine squared beta is 64 over 100 and cos square beta is 36 over 100. If you sum it, they give the same answer. You can see that it is clear that once these angles are the same, if you square sine and the cos there, once the angles are the same, it will eventually give 1. It's a fact. Now, please, if you like this video, please help me subscribe and hit the notification button. Once this appear, you'll be able to have access to it. Have a nice time. See you in my next version.